Hey, what's up everyone? This is your friend Sanjay, and in this video we are going to understand Archimedes Principle and Upthrust. Friends, we are aware of Archimedes and his story. Once he was thinking something about a problem that was asked to him by the king, and after trying several times he didn't get the answer, and once he was bathing he found the answer, and he was so happy that he ran naked throughout the streets shouting Eureka and Eureka. Right, so let us understand what did he understand then which made him to do such a funny act. So to begin with that, first let us understand upthrust. What is upthrust? Upthrust is a force acting normally in upward direction. Okay, so when I am saying normally, it means at 90° perpendicular. So any force acting perpendicularly, that would be called as thrust. But when I am saying that the force is acting normally and in upward direction, it would be called as upthrust. Simple. So if I have a glass of liquid, any liquid, for example water, so definitely this water has a tendency to do lot of stuffs. So if I drop a coin, this coin is going to reach the bottom of this glass, but definitely not as quicker that it will go in absence of water. Here it would reach the bottom of glass slowly. Why? Because water will exert some force on this coin in upward direction. So this coin has to resist that force, and it will go in that resistance that it offers to the upthrust. The coin will go slowly. Here in this case, in open air, it has not got any sort of upthrust, so it will definitely travel faster towards the bottom. So this is an example of how upthrust acts. Okay, now Archimedes principle is all about calculating the value of upthrust. You can actually get the value of upthrust. So let us first understand what is Archimedes principle, and then we'll try to correlate that with upthrust. Okay, now just taking a can, simple overflowing can, overflow can, and this can is filled with a liquid, any liquid you can take. For simplicity, you are just taking water in it. Okay, and in this can, if you are dropping a piece of stone, this is a stone, and you are dropping this stone into it, what will happen? Definitely this stone will push some of the water away from the beaker, and it will get released outward, and you will collect that in another vessel. Okay, so this is quite natural. In case if you don't have a overflow can, what will happen? This level of liquid will rise. Instead of flowing outward, it will rise upward. Okay, but because we have chosen overflow can, we can collect the liquid in another vessel. Okay, now as per Archimedes principle, the volume of stone is equals to volume of displaced liquid. Yeah, volume of stone is equals to volume of displaced liquid. Okay, so you may say that what's so big in this experiment, what's so great about this experiment? So for that question, there is a very simple answer. If you have something like a sphere, something like a cylinder, okay, sphere, cylinder or cone, hemisphere, so these shapes about which I have spoken, all of these shapes are regular shapes. I mean, they have a fixed formula to determine the volume of these shapes. But if I am taking the example of this stone, if I am taking the example of this stone has not got a specific shape. It's not a defined shape. So because of that, it is very difficult for you to find the volume of this stone. So in that case, you can easily find the volume of this stone by dropping it in water and just see how much water is expelled out, and the volume of this water is exactly the volume of the stone, and that's what is Archimedes principle. Hope you got it. What is Archimedes principle? This is the simplest example of Archimedes principle. Now you cannot say that Archimedes principle is just one line statement, volume of stone is also volume of displaced liquid. There are similar equations which tells the same thing, which suggests the same thing. Okay, now here upthrust is coming into the picture. Upthrust. Okay, so as per Archimedes principle, one way of finding upthrust is weight of the displaced liquid. Weight of the displaced liquid. Okay, so whatever liquid is collected over here, if you are finding the weight of this, that weight is going to be exactly equal to the upthrust that will act on this stone by this liquid. Isn't it interesting? And definitely we do have a proof of this, but in this video I am not going to deal with that proof. Another formula for upthrust that you can get by Archimedes principle is upthrust. Yeah, anything which weighs around 10 kg outside water will weigh less than 10 kg in water for surely. You can check it. So that difference in weight is exactly equals to the upthrust. So this is another way of finding the value of upthrust, and this is nothing but Archimedes principle. The third way of determining the upthrust is saying, so because there was certain weight before dropping and there was certain weight after dropping, I mean before dropping the weight is in air and after dropping the weight is in water. So there is some loss in weight. This loss in weight of the solid is also upthrust. So this statement is actually not a different term, it's the same thing. The difference, this difference is nothing but loss in weight of the solid. Hope you understood it. Thanks.